So in this video, we're going to use the values of a, h, and k to start identifying some key information from our quadratic graph function. And to start, we're just going to look at h and k specifically because there are some really key components we can actually pull out of this equation, and it will help us as we actually start to graph these types of functions later on. So if I open up Desmos again, what you'll notice here is I have 4 different colors on the graph. And what we're going to do is we're just going to focus on one at a time. Yes, I recognize there are a values here, but don't let the a values fool you. They're just a part of the graph. We're going to focus specifically on h and k here. So let's look at this graph in red first. H is currently set to -4, and k is currently set to 2. And I want you to take a look at the vertex. See what you can pick up on. And then this next graph here in blue, I want you to look again, my vertex. So I'm going to get both. Let me see if I can get both on the screen. There we go. So the graph in blue, we have an h value of 3 and k value of 4. Here's our vertex. In green, h value of 7, k value of -2. There's our vertex. And the purple graph, we have an x value of -2 or an h value of -2 and a k value of +2. And look at that one. So take a look at these. Look at the h values. We have -4, 3, 7, -2. -4, 3, 7, -2. What I notice with these h values is these h values, if we take the opposite of all of these h values, so we take -4 becomes 4, 3 becomes -3, 7 becomes -7, and -2 becomes +2, we actually find the x-coordinate of our vertex, which is kind of helpful. If I can just look at the equation and find part of my vertex, it eliminates a large portion of the work for me as I start to graph these. The other thing that I notice is I have a k value of 2, 4, -2, and 2. So what I'm noticing here is my h value, it's the opposite of the x-coordinate of my vertex, and the k value actually matches the y-coordinate of my vertex perfectly. So I can actually identify the vertex from the equation, which is really, really convenient. So that's why this is called vertex form, because your vertex of your quadratic is, I'm going to use a negative here, the opposite of h, comma, k. That's actually how we identify our vertex, is we take the opposite of h, and we then keep the k value, and that is our vertex of our quadratic. So what we're going to do here is we're going to, for each of these, find the vertex, and then as a result, find our axis of symmetry from each equation written in vertex form. So here we start off and we notice we have y equals 2 x plus 4 quantity squared minus 6. Well, I'm just going to make some notes down here. So first thing that I know is just from looking at the a value, this graph is going to vertically stretch. I can see that from my a value. Then from here, I can see that my vertex is going to be the opposite of what h is. So h here is a +4. My vertex is a -4, comma, whatever k is, which is -6. And then my axis of symmetry, remember, has to have an x value that matches the vertex because they lie on the same. So the vertex is on the axis of symmetry. So I have x is equal to -4. So I'm able to identify all of that information just by looking at this graph. The 2 will stretch it, my vertex will be -4, -6, and my axis of symmetry will be -4, or x is equal to -4, that vertical line there. Now if I move on to this next one here, I notice that this graph is going to vertically stretch and flip based on that a value of -3. I then notice that I can identify my vertex since this is written in vertex form. So my vertex is going to be the opposite of h, which -2 becomes a +2. And then from here, a -5 I would keep as is, and that would be my y value of my vertex. So it's the opposite of h, comma, k. Then from here, my axis of symmetry, again, needs to match the x-coordinate of my vertex, so it would be x is equal to 2. All right, moving on to the next one. And we're actually going to switch one of these out here. So I'm going to move this one up here. We're going to eliminate these. And we'll just do 2 more. So here, again, let's look at the key information that we can identify. So this -4 means our graph is going to vertically stretch and flip. I then need to identify my vertex, which my vertex is going to be the opposite of h, so it's a -5, comma, k, and there's no k. But what I want you to remember here is that really when there's no k out here, there is a k value. They're just not writing the +0 that should be out there, just as redundant. So here, this is -5, comma, our k value of 0. So our vertex would be -5, comma, 0. And then our axis of symmetry point or line matches the vertex point. So you would have x is equal to -5. And then finally here, our last one, our a value is telling us this graph is going to vertically stretch and flip. And then notice I need to find my vertex, and my vertex is the opposite of h, comma, k. Well, I can see that k out here is outside the parentheses, so that is 3. But what's tricky to me here is that we don't have a value in the parentheses with x, so it's really hard for me to see what h actually is because it needs to be in the parentheses being squared. Well, what's really happening here is there's really an x plus 0 inside of those parentheses being squared. So in this case, my h value is really just 0. So don't let the fact that there's no parentheses here fool you. H is just plus 0, and then your k value is along the outside. And then our axis of symmetry line would be x is equal to 0 because it needs to match our vertex. So we can find a lot of information here just from these equations, and it kind of eliminates some of that calculating work that we have to go through in order to graph our quadratic functions. So we're now going to use this as we move forward in graph to help us identify this key information before we even start calculating points and graphing.